What is a container? What is this thing called Docker? What is Kubernetes? Right. This is what it is. The picture sounds or appears a little complex, but it is not as complex. It is fairly simple. I'll tell you how it works. I have a hardware machine on which I install the operating system. In a virtualized data center, what I would do, I would not install an operating system. Instead, I would install a hypervisor. And on the hypervisor, I would provision virtual machines, right? So here it's a little different. That is hardware virtualization. But what is this containerization? Docker, I'll come to later. The term containerization is important. The containerization is nothing but OS virtualization, which means on the server hardware, I install the operating system. Maybe it is a Linux server, RHEL 8, or Ubuntu, or CentOS, or it is Windows Server 2016 or 2019, whatever. I install the operating system. Practically, if you see, it will be a Linux operating system. I'll tell you the reason also. And if I take, let's say, CentOS, if I install CentOS here, I would like to build a C program on Red Hat Linux. Now, if you're from a Linux background, you'll know that all Linux have the same kernel. The distributions have their own differences, all right, but the kernel is the same. So what happens is, the kernel part of this operating system is taken, and what is not here of Red Hat Linux, that alone I would like to install. So operating system on an operating system. The binaries, libraries which are not part of this, which are part of Red Hat Linux, I will install that here. So that is going to be called a container. Similarly, I might have SUSE Linux here. I might have Ubuntu Linux. I might have Alpine, several flavors of Linux. Now you get to understand why Linux is popular in the containerized environment, because you have a base Linux and you have different flavors of Linux. So Linux on Linux. Okay, how do I run that? There should be something in between. There should be a layer. There should be something that interconnects these two stuff. And that is called your container engine. And the most popular container engine, which is ruling the entire space, is called Docker. So Docker is actually the container engine which helps me to deploy the Red Hat Linux on a CentOS, Ubuntu Linux on a CentOS. So it is like running, instead of running multiple virtual machines on a virtualized hardware, I run multiple operating system based applications on a single operating system using the container engine, which is called Docker in our case. I hope the concept is clear.
Vijay, one question. So is this very similar to an hypervisor, a VMware hypervisor?
Like I said, you can draw an analogy between the hypervisor and the Docker engine, but a hypervisor virtualizes the hardware, whereas the Docker engine virtualizes the operating system. That is where the difference is. Are you able to get that?
Yeah, correct, understood.
Yeah. So once that is done, then inside this Red Hat Linux or Ubuntu or whatever, then I install my dependent language. If I'm going to build a microservice on C++, then I have the C++ environment here, and on top of which I input my code. So this becomes a new package. This is a Ubuntu Linux. I want to install Node.js application, and then I want to put the Node.js code on this. This becomes a new package, and everything becomes a new package. I can store that in a repository, It is actually not, it is going to be called, once I've readied up my deployable package, I would be calling that an artifact. I put the artifact into a repository, and that would be taken when I'm going to deploy the whole stuff in production. Okay, so let's go a little more into this. This will help you understand the entire thing very easily. So this will be my environment. I have a hardware on which I've installed the Ubuntu operating system. Let's say I'm just taking an arbitrary Linux flavor. Ubuntu is installed. Okay, and this is the hardware on which I've installed Ubuntu. And on top of that, I have installed the container engine, which in my case is Docker. So what is my idea? My idea is to run containerized applications here, which means I might want to have a web server, maybe. I want to have application also running, web application, etc. So all these things will require, let's say I'm going to build them, will require a base server or a base container. If I'm going to build on, let's say, Red Hat Linux, I need a Red Hat Linux container which runs here. If I'm going to build it on a CentOS, I need a CentOS container which runs here. And all these container images, that's what we call. If I'm going to run it here, it's going to be called a container. If I don't run it and I've kept it as a file, as a template, that is called an image. All these images of containers are kept in a public repository, and the one of the most popular public repositories called Docker Hub. You will find all the standard images here, Docker Hub. So what am I going to do? I'm just going to create my own account here. These are all open source. So many things are available here. I will create an account in Docker Hub, connect it to my machine where I've installed the Docker engine, and I would simply pick up an image using a pull request. And if you can observe this, this is already a HTTPD image, which means someone has already created a web server and kept it ready for me. I can either have a blank server without any service being installed. I can choose the service of my choice. Or if I know that I need a web server wherein I can install my pages directly, I directly choose the image of a web server. It's already available, the Apache web server. So I can simply pull the web server image from the Docker registry, which is the Docker Hub in this case. Bitbucket is another example. And I can run a container using this image. So please understand the terminology. As long as this is just an image or just a template, it is called a Docker image. Container image. Whereas if I'm going to run it, the runtime is going to be called a container. Now this is a web server. This will get an IP address. I paste this IP address on the browser, I'll be able to see the page. Of course, I should have loaded the web page inside. Right? So similarly, I can pull whatever I want. If I have created my own, I can store that, or I can make use of the public registry, and I can run containers of my choice. Now I'm running a web server, which is Apache web server here. And in this case, I want to build my own application. So I get a blank Ubuntu image, and I just run the Ubuntu server here, container here. Ubuntu on Ubuntu, possible. That means the libraries, etc., they are all divided into layers. Whatever is duplicated, that will not be downloaded. When it pulls here, when you run it here, what it will do is, it will only run, or it will only pick up those layers which are not available here. Only those layers are picked up and run. Now what I do, I build my code, install my application into the container. And once that is done, I can either operate this here itself. Whenever I want to run it, I stop it. Or if I want to start and run this container and start using it here, I can do that. Or if I've readied this to be deployed later, I can once again convert this container into an image and store it locally. If I've readied this to be deployed anywhere, I can create my own repository in Docker Hub and push the image into the Docker Hub. The repository allows me to configure it to be public or private. If I make it public, anybody can, who knows this URL, he can browse, he can search, he can pick this up, he can use it. However, if I want it for my own use, I would define that as a private repository and store it there and retrieve whenever I want. I hope you get the entire picture now. What is the role of a repository? What is the entire story of Docker's containers? Any doubt, anyone? I think someone got out. So let me admit it. Any doubt, anyone?
So Vijay, Santosh here again.
Yeah.
So this Docker container engine, is that a standard, or you have different providers?
Yeah, different providers are there. Docker is the most popular one, container engine. You have CRIO, lightweight. You have some other stuff also. But
Okay,
Docker is the most popular.
Okay,
yeah.
In this picture, is Kubernetes coming in, or we haven't started that topic?
Yeah, that comes next.
Okay.
Yeah, I guess I see one more query about the IP address. It is very similar to giving the IP address to a guest operating system in a virtual machine. So this also would have a IP address. We will use that IP address to access. How will you manage it? Whatever you think of as an infrastructure guy, similar stuff could be implemented. You have what is called as a Docker network. And in the Docker network, you need to configure. You have several modes. Depending on the modes, you can share the host IP address to the containers, or different mapping stuff. Yeah. Okay. If you say container IP, I should clarify there that the host has the IP and it maps different ports to different containers. We might not have individual IPs to the containers. We'll have IP to the host, and it will map to the different container port numbers. No, like I clarified, now we are discussing only about the single hardware, and this single hardware is going to have one IP address. This will run on its service on a certain port. This will run on a different port. So this host will map this IP address to this port number or this port number. That's how it is normally done. All right. Now, whatever we have discussed so far is about a single host, right? I can destroy whatever I don't need also. Now, what do I do when I have to manage multiple such containers on multiple hardware? My environment is huge. So I need to have, let's say, 10 hardware on which I either run VMs or I run containers. How do I manage them together? What is the control plane? What is the management software? That is where we need something to orchestrate the entire containerized environment. And here's where you come across terms like Docker Swarm, Mesos, or Kubernetes, out of which the most popular management engine has been your Kubernetes. The other ones are Mesos, Docker Swarm, common examples. But since Kubernetes is the market leader when it comes to managing multiple containerized nodes, we would like to understand how that is architected. It has got a master node where all the control functions work. And then it has got the worker nodes, which is where your containers actually run. And the containers run inside a logical unit called pod. Right? So this is one hardware, the Kubernetes master node, where all the controls run. Anyone who wants to access the entire cluster, Kubernetes cluster, access it via the Kubernetes master, and that is again through the API. It has got a built-in API component. So whether it's the administrator or the developer who wants to access the cluster for whatever activities they want to perform, they will connect over the API component to the master and issue the commands or work on the entire cluster. Once the Kubernetes cluster is implemented, Docker engine runs everywhere. You have created pods inside which the containers run. Once the entire environment is ready, then you, let's say this is running an application, an e-commerce application again, like Amazon.com, Flipkart.com, it opens up for internet users. The users are then allowed to access whatever they require to using these components called the proxy or the kube proxy. So rather than visiting and briefing on this complex environment in this picture, let me show you a small animation again. I'm going to have one master node on which my control functions exist, and it is connected to two worker nodes. These three together constitutes my Kubernetes cluster. And if you can see, the worker nodes where I have installed your Kubernetes, where I've installed your Docker container engine, the Kubernetes component is going to run something called as kubelet. And this is responsible for handling stuff at the worker node level. So let's say, as an administrator, I wish to provision a container inside a pod. So what I have to do is I have to connect to the master node via the API and give my instruction to create a new pod. Now API is just an interface. It does not do anything by itself. It's just a connecting interface. It just picks up my request and passes it on to the relevant component. The relevant component in this case is a scheduler. Scheduler again is a built-in component of the master node. It is responsible for figuring out which worker nodes are free, lesser load, which is ideal for creating the new pod. And it will convey the instruction of creating a new pod to the kubelet of that particular worker node, which creates the container pod. What is the difference between a pod and a container? A pod may contain one container or probably a dependent container. A use case may be a container is running an application. Another dependent software will run the monitoring tool, that would be another container. So these two together could be one pod. Dependent set of applications. So if I need one more pod, let's say, so the scheduler will now figure out that the first worker node has already got a pod, so the one which is free is the second node. Immediately it will instruct the second worker node's kubelet, which will create a pod on its node. That's what a scheduler does. You can also order a replica set. I want a replica set for a higher load. It will instruct both the kubelets and both of them would land up creating pods. All right. What happens if something goes bad? Before that, the status of each of these pods, what is their configuration, what is their state, all that has to be stored somewhere. and that is the etcd component of the master node. This is a folder directory which keeps track of all the configuration status, etc., which will be used for referencing whenever there is a failure. So what is the role of an orchestrator? It is not only provisioning, but also tracking if something has failed and ensuring that a replacement pod is created in its place. And that's the role of a control manager. So this guy, controller manager, tracks all the pods, gets to know their status from the etcd, and whenever something goes wrong, something goes down bad, it will auto heal the whole environment by recreating another pod which is the equivalent of what went wrong. This, in summary, shows you the most important constituents of your Kubernetes cluster. And you can see that the users have nothing to do with this. The users are directly going to hit the outputs using the kube proxy.
Yes.
So once we are done, then come in the users. The users, when they want to access, they will access the kube proxy, which will put them on to the relevant container, which they are supposed to intend to access. So that's the final picture. On one side, it is about control. This could be developers or administrators. Depending on their task, they will access the cluster and work on it. On the other side, there are users who are going to access the services offered by this application, for which kube proxy is the entry point. So that defines the popular environments of today: the serverless, the containerized environment, how it is orchestrated using Kubernetes.